Hey everyone, and welcome. If you're working with .NET, you already know that dependency injection is a huge deal. But really, truly mastering it, that comes down to understanding service lifetimes. Getting this right is the key to building apps that are not just fast, but rock solid. So today, we're going to dive in and turn you into a DI Lifetime Pro. So let's kick things off with a little mystery. Imagine this. Your app is humming along in production, everything looks great, but then, like clockwork, every 8 hours or so, it just restarts. You check the logs and there's nothing. No exceptions, no warnings, not a single clue. This isn't a hypothetical. This is a real-world production nightmare, and it's usually caused by a silent, sneaky memory leak. And today, we're going to be the detectives who solve this case. All right, to crack this case, we need to get familiar with our investigation tools. And in the world of DI, our main tools are the 3 service lifetimes. Now, it's easy to think of these as just a performance thing, but there's so much more. They are a contract, a rule that defines how long a service gets to live and who is responsible for it. And you know what? These concepts are actually super simple once you have the right analogy. Think of it like this. A transient service is like a disposable paper cup at the water cooler. Every time you need a drink, you grab a brand new one. A scoped service? That's your personal coffee mug you keep at your desk. It's yours for the whole day, or in our case, for a single request. And the singleton? That's the big clock on the office wall. There's only one, everyone in the entire building looks at the same one, and it's there for good. Okay, let's zoom in on transient. When you register a service as transient, you're telling the container, hey, every single time someone asks for this, give them a fresh, brand new instance. This is perfect for small, lightweight services that don't hold any state, like a simple calculator or a data mapper. Since nothing is shared, it's always safe and clean. Next up is scoped, and honestly, this is the workhorse for most web apps. Here's how it works. For every single HTTP request that comes into your application, the framework creates a little bubble, or a scope. Any service you've registered as scoped gets created once, and only once, inside that bubble. The classic #1 example of this is a database context, like Entity Framework's DbContext. You want all the different parts of your code handling that one request to share the exact same database connection and transaction. Then, once the request is finished, poof, the whole scope is destroyed and the DbContext is cleaned up. Perfect. And that brings us to the big one, the singleton. This is for those services that need to be global, shared across every single part of your application for its entire lifespan. We're talking about things like your logging service, your configuration provider, or maybe a global in-memory cache. There is only one instance, ever. Which brings up a super important point. If that singleton holds any data that can be changed, it must be thread safe. But really, the best singletons are the ones that are totally stateless. Okay, so we've met all the players in our story. Now it's time for the plot twist. Remember that mystery of the app that keeps restarting? Well, the culprit is a really subtle but totally devastating bug. It's a true villain in the world of dependency injection. But before I name the villain, you need to know the law that it breaks. This is the golden rule of DI lifetimes, and you should probably write this down. A service should only ever depend on other services that have a lifetime that is equal to or longer than its own. So a scoped service can totally depend on a singleton, no problem. But a singleton should never, ever, ever depend on a scoped service. That's where things go wrong. And this brings us to the name of our villain, the captive dependency. This term, which was coined by Mark Seaman, is just perfect. It perfectly describes what happens. The longer-lived service, our singleton, basically kidnaps the shorter-lived one and holds it hostage for its entire life. Let's break down the crime scene here. A singleton is born once and it lives forever. A scoped service is supposed to live for just one request and then be disposed of. But when you inject that scoped service right into the singleton's constructor, the singleton gets a reference to it and just never lets go. That scoped service never gets disposed. It's now effectively become a singleton itself, and any memory or connections it's holding onto are leaked forever. So how does this actually translate into that slow, silent memory leak? Well, under the hood, the DI container makes a promise. If it creates an object that implements iDisposable, it's responsible for calling dispose on it later. So when the main application container, the root container, creates your singleton, it also creates that captive scoped service. To keep its promise, it adds that service to a special internal list of things to dispose of later. But here's the trap. The root container lives as long as the application does. That list never gets cleared. It just grows and grows and grows until your application runs out of memory and the container orchestrator has no choice but to kill it. Mystery solved. Now, the good news is the .NET team is well aware of this danger. In a modern ASP.NET Core app, there's a feature called scoped validation that's turned on by default. If you even try to inject a scoped service into a singleton, your app won't even start. It'll throw this big, loud, and very clear invalid operation exception. This is your first line of defense, and it's a great one. It's screaming at you that you're about to create a captive dependency.
Okay, we found the bad guy. We understand the crime. So how do we fix it? What if we have a legitimate reason for a long-lived service, like a background worker, to use a short-lived one, like a DbContext?
Well, meet the hero of our story, IServiceScopeFactory. This is a beautifully simple tool that the framework gives us. It's actually a singleton itself, which means it's totally safe to inject anywhere. And its entire job is to give you the power to create brand new temporary scopes whenever you want. And this leads us to what we call the safe pattern. It's a really simple 5-step process. 1. Inject the IServiceScopeFactory into your singleton. 2. For whatever chunk of work you need to do, create a new scope inside a using block. 3. From that new scope, ask for the scope service you need. 4. Do your work. And 5. When the using block finishes, the scope is automatically destroyed and it takes all of its services with it. No leaks, no captives, just clean, safe code. Let's see this in action with some real code. This is a super common scenario. We have a background service, which is for all intents and purposes a singleton. Now notice, we are not injecting my DbContext in the constructor. No way. Instead, we inject our hero, the IServiceScopeFactory. Then, down in the execute async method, that using block creates a temporary scope just for this one operation. Inside that block, we can safely grab our DbContext. As soon as that block is done, the scope and the DbContext are gone. It's clean, it's safe, and it's leak-proof. This is the way. So we solve the mystery and we learn the right pattern to use. But the real win is learning how to avoid these problems from the very beginning. And that means thinking about dependency injection as a fundamental part of your application's architecture. And here's the most important takeaway. Your choice of service lifetime should be driven by the service's job, by its responsibility. Is its job to manage state for one single operation? Well, that sounds scoped. Is it a stateless little helper function? Transient is probably a good fit. Is it a global cache that everyone needs? Then okay, it's a singleton. Don't just pick singleton because you think it's a tiny bit faster. Pick it because its responsibility is truly application-wide.
And hey, if you are going to use singletons, you have to follow the rules. Rule number 1, if it has any state that can change, you absolutely must make it thread safe. But you know what's even better? Just design them to be completely stateless from the start. It makes them way easier to test, way easier to reason about, and it prevents those bizarre bugs where data from one user's request suddenly bleeds into another's.
Here's another pro tip for you. If you ever look at a class's constructor and see a giant list of like 10 different services being injected, that is a massive red flag. We call that a code smell. It's a sign that your class is trying to do way too much. It's breaking the single responsibility principle. The solution here isn't some clever DI trick. It's to go back to the drawing board and refactor that monster class into smaller, more focused services. And by the way, mastering this stuff isn't just about writing good code. It'll help you land your next job. These are classic technical interview questions. You should be ready to explain the difference between scoped and transient on the spot. You should know exactly how to solve the captive dependency problem using IServiceScopeFactory. And you should be able to explain why it's so important for singletons to be stateless. So I want to leave you with one final thought to chew on. When you're in your code and you write .addScoped or .addSingleton, you're not just asking the container for an object. You're making a fundamental architectural decision. You're defining that service's entire lifecycle and its ownership boundary. Get that right, and you'll be building clean, stable, and truly scalable applications. Thanks so much for joining me.